All right, everybody, welcome to Math with Grace. For this video, we're going to be looking at Algebra, Unit 4, Lessons 6 through 10. Lesson 6 begins on page 22, and it's entitled Multiplying Binomials. And it tells us here that to multiply a binomial, which is two terms, right, by a monomial, one term, we use the distributive property. And here's the example, right? They drew under, that's fine. 4x times 2x, we multiply the 4 times the 2 and get 8, and we multiply the x times the x and get x squared. 4x times the 3, we multiply the 4 times the 3 and get 12, and then the x just tags along because there aren't any other variables to multiply it with. Two binomials can be multiplied using the distributive property as well. So here are the two binomials. We have the quantity 2x plus 3 times the quantity x minus 5. And it's basically the same as taking this 2x times x minus 5 and this plus 3 times x minus 5. Okay, and so that's what they've done here. Now they've got a few basic methods to do this type of work, okay? And method 1, and here they have this method. I'm not sure why it's not considered a method, but it's not. So method 1 is called the vertical method, and that's what we have here at the bottom of page 22. So for the vertical method, they stack our binomials like you would stack a regular multiplication problem, all right? So we have 2x plus 3 times, I'm not sure, I mean, they put it in parentheses because it's just showing that we're multiplying, times x minus 5. So just as with a regular multiplication problem, we start on the far right of the bottom of the two things, right? And so we take negative 5 times 3, and we get negative 15. Then we take our negative 5 times 2x, and we get negative 10x. Then we when you used to do this with multiplication, you cross that one out, you put the 0 to hold its place. They don't really do that, but I'm going to go ahead and do that. And then you take the x times the 3 and get 3x, and the x times the 2x and get 2x squared. Then we add those together, right? Negative 15 plus 0 is negative 15. Negative 10x plus 3x is negative 7x. And then there's nothing to add the 2x squared to, so it just drops down, and that would be our answer. So let's do some of these problems in the vertical method. So I'm starting down here with number 1, and I've got the quantity x plus 2 times the quantity x plus 3. So we rewrite it, x plus 2 times x plus 3, and we draw our line, right? And then we take 3 times 2 is 6, and 3 times x, that's positive 6, 3 times x is 3x. I'm going to cross out my 3 and put my 0 down, and then take x times 2, and that's going to be 2x. And then x times x, which is x squared. Now I can add these things together, all right? 6 plus 0 is 6. 3x plus 5x, 3x plus 2x is 5x. My mouth getting ahead of me here. And the x squared just falls down because there's nothing to add it to. And so our answer is x squared plus 5x plus 6. Looking at number 2, we have the quantity x minus 4 times the quantity x plus 5. So let's write these in the vertical method. Times x plus 5. And then we say positive 5 times a negative 4 is a negative 20. Positive 5 times x is 5x. We can cross out our 5, put our 0. X times a negative 4 is negative 4x. X times x is x squared. Negative 20 plus 0 is negative 20. 5x minus 4x, so if you had 5 x's and I took 4 away, you would only have 1 x left, and it would be positive, plus this x squared. In these cases, our x squared is always going to be by itself. just like our constant over here is always going to be by itself. The only adding that's going to take place is right here in the middle, okay? So our answer is x squared plus x minus 20. Looking at number 3, we have the quantity 2x plus 1 times the quantity x plus 2, or sorry, x minus 2. So 2x plus 1 times x minus 2. Negative 2 times 1 is a negative 2. Negative 2 times 2x is a negative 4x. Cross out my negative 2, put my 0. X times 1 is x, right? Positive. X times 2x is 2x squared. Now, like I said, our only adding we're really going to do here is in the middle. So my negative 2 drops down. Negative 4x plus x. So we went down 4x times, but then we went up 1x. So we have a negative 3x. And then my 2x squared drops down. And so my answer is 2x squared minus 3x minus 2. Okay? Let's do one more up here at the top of page 23. Let's take a look at number 6. For number 6, we have the quantity 3y minus 6 times the quantity 2y minus 3. So for the vertical method, we stack them, 3y minus 6 times 2y minus 3, and we multiply. Negative 3 times a negative 6 is a positive 18. Negative 3 times a 3y is a negative 9y. I can cross out and give us quite enough room here. Cross out my 3, put my 0 just to hold the space. 2y times a negative 6 is a negative 12y. And 2y times 3y gives us a 6y squared. So now I add them together, right? 18 plus 0 is 18. Negative 9y minus 12y, so we're going down and then down some more, gives me a negative 21y. And then I've got my 6y squared, okay? That one's cutting it kind of close here, because then we have method 2. But before we look at method 2, because method 2 is really what we'll use going forward. It's the FOIL method. They call it the horizontal method, but really it's the FOIL method, okay? That's the method that I will use moving forward. And if you're comfortable, hopefully you learn to get comfortable with it and use that as well. The vertical method is okay. It just takes up a lot of space. So let's look at method 3 before we dig into the FOIL method. They don't even make you do any examples because method 3 is so dumb. But it's called the grid method, okay? And basically what you would do is draw a 2x2 grid, kind of like you do in science class, right? And then you multiply the parts of the grid together. So you would take the 2x times the x and get 2x squared. You would take the 3 times the x and get 3x. You would take the 2x times the negative 5 and get negative 10x. And then the 3 times the negative 5 and get 15. Add these boxes together and get your answer. Now, you could use the grid method, but they know that the grid method is really kind of out of date, and so it's not very used. So let's go into method 2, which is called, they call it the horizontal method, but really we call it the FOIL method. And you'll see right here why. So when we're doing the FOIL method of multiplying two binomials together, we want to do first, we multiply the first terms. So we would multiply the first terms in each binomial, 2x times x, and you get 2x squared. Then you would multiply O, or the outer terms, which means the terms on the outside edges of the multiplication problem. The 2x times a negative 5, which would give you a negative 10x. The I means you multiply the inner terms, so the two terms on the inside. 3 times x was 3x. And then the L stands for multiplying the last terms. So it would be the last term of each binomial. So the 3 times a negative 5 gives us a negative 15. These still need to be added, okay? And then we can get our final answer. So let's look at the FOIL method here with the rest of these problems. So for number 7, we have the quantity x plus 4 times the quantity x minus 6. So FOIL method tells us that we go and we do the first terms. So x times x gives me x squared. Okay? Then we do the outer terms, or x times a negative 6, which gives me a negative 6x. Then we do the inner terms. 4 times x is a positive 4x. And then we do the last terms, 4 times a negative 6, or a negative 24. Now I have to combine my like terms here, and then we're done. So we have x squared, and then we have negative 6x plus 4x, which gives us a negative 2x minus 24. Now they call this the FOIL method. It has a little anagram or whatever, but really it's just the distributive property. You took this term times that one, then you took that term times the other, right? Then you took the 3 times the x, and then the 3 times the negative 5. But FOIL method helps people remember, so we're going to go with the FOIL method. First, outer, inner, last. First, outer, inner, last. All right, so number 8. First, we take m times m and get m squared, okay? Outer, we take m times a negative 2 and get negative 2m. Inner, 10 times m gives me a positive 10m. Last, 10 times a negative 2 gives me a negative 20. We combine these like terms. So we have m squared. Negative 2m plus 10m gives me a positive 8m minus 20. All right. Number 9. The quantity y minus 7 times the quantity y minus 7. Now this one has special properties that you haven't learned yet, so we'll look forward to doing these again in the future. But for now, let's just use the FOIL method. First, y times y is not 2, anything, is y squared. Y times a negative 7 is negative 7y. Negative 7 times y, we're on inner, is negative 7y. And then last is negative 7 times negative 7, which is a positive 49. Got to combine our like terms, but we have y squared. And then we have negative 7y minus 7y. Down, then down some more to a negative 14y plus 49. All right. Looking at number 10, we have the quantity 3x plus 1 times the quantity 2x plus 1. So we do the first. 3x times 2x is 6x squared. The outer, 3x times a 1 gives me a positive 3x. The inner, 1 times 2x gives me a positive 2x. And the last, 1 times 1 is 1. We've got our like terms here in the middle. So we have 6x squared. 3x plus 2x is a positive 5x plus 1. All right, so you can see why I prefer the FOIL method. It's much, it takes much less time, right? Less space. They don't always give us a whole ton of space to do our work like this one. So I prefer the FOIL method. So let's keep going. For number 11, we have the quantity 4y plus 8 times the quantity 3y minus 6. First is the 4y times the 3y, or the 12y squared. Outer is the 4y times a negative 6, or negative 24y. Inner gives me my 8 times my 3y, or a positive 24y. And then last is 8 times a negative 6, which is a negative 48. I'm crimping in on here, number 12 here, negative 48. So if you look at our middle terms here, there's something kind of special. But we have 12y squared. And then we have a negative 24y plus 24y. Well, 24 minus 24 is 0. 0 times y is 0, so they're actually gone. And so all we're left with here is our 12y squared minus 48. So this middle term can eliminate itself, and it does quite often, honestly, when we're doing these kinds of problems. So number 12, last one. quantity 2b minus 7 times the quantity 5b plus 4. We do first 2b times 5b, or 10b squared. Outer is 2b plus or times a positive 4, so that's a positive 8b. Inner is negative 7 times 5b, or negative 35b. And then the last is negative 7 times a positive 4, or negative 28. There it is. All right. We got to combine our middle terms here, right? But we have 10b squared plus 8b minus 35b, okay, which is going to give us a negative 27b minus 28, okay? And that's our answer. All right, so when we're multiplying binomials, remember, when we just have a monomial times a binomial, we're just going to have to distribute, right? Just like we've been distributing in the past. But when we have a binomial times a binomial, the best method to use, the easiest and most efficient method to use, is the FOIL method. First, outer, inner, last. All right? We add up our like terms and we get our final answer. Great job. Lesson 7 begins on page 27, and it's about graphing ordered pairs. Last week we worked on finding ordered pairs, okay? This week we're going to talk about graphing them, and there are some words to know here. Make sure you review those and become familiar with them. But basically what I want to look at here is we're used to graphing an x equals on a line, right? It's a dot on a line. Well, now we're going to add basically this y equals. We're going to put them together, and right here we have a coordinate system, or the coordinate plane. It says that this system for graphing ordered pairs is called the Cartesian Coordinate system. So we really just call it the coordinate plane or the coordinate system. The horizontal line is the x-axis. The vertical line is called the y-axis. And where they intersect, okay, where they cross each other, the point 0, 0 basically, is the origin. Now, the x value is referred to as the x coordinate, and the y value is the y coordinate. So let's turn the page and keep talking about this. Now, to graph or plot an ordered pair, we need to remember that our ordered pairs are listed as x, comma, y. The x is always first, and so that's what we plot first. So we graph horizontally by our x value, and then we go vertically by our y value, and we put a dot. So for this point, 3, 3, okay, positive 3, so we went the positive direction on the x first, and then we went this positive 4 in the y, and we put our dot. For the point negative 2, 2, here our x is negative, so we go to the negative to the left 2 points, and then we go up 2 points, and we put a 2. It's kind of like Battleship, if you've ever played Battleship before, right? You have to kind of match up the coordinates to pick the right spot to bomb, right? So that's what we're doing. We're matching up a negative 2 and this positive 2, negative 2x, positive 2y, and we're seeing where they would meet, and that's where our dot goes, okay? So then when we look at these, we can see that the axes, the x-axis and the y-axis, here's our x and here's our y, divide our coordinate plane into 4 areas. These 4 areas are called quadrants. And we start with this quadrant here because both of the terms in this quadrant are positive. So when both terms are positive, that's quadrant 1. And then they go counterclockwise around. So if you can find quadrant 1, then you just go counterclockwise and number them. And they're always in Roman numerals. So here's quadrant 1, 2, 3, 4. Okay? They look like little faces. It's kind of cute. Here's a winky face, right? Anyway, So those are our quadrants. They're going to ask you questions about them, right? Label the points and what quadrant they're in. The example is not the greatest one to go by because everything's kind of already done for you. So let's just jump into the lesson and do these problems together, and that will be our example, okay? So for problem number 1 through 4, they want us to write the coordinates of the points on this graph, all right? So starting out with point A, we can see that point A is over here. We're writing its coordinates, so it's going to be in the form of x comma y, all right? So what is our x? Well, here's our origin point. That's where you always start. That's where you start your journey. And from the origin, 0, 0, how far do I have to move horizontally for my x value? Well, I'm not going into the positives, right? It's over here in quadrant 2. So I'm moving to the negatives, and how far? Well, I have to go to this -4. So that's my x value, -4. And then vertically, how far do I have to move up the y-axis to reach that A point? Well, I'm going up, so I know my y is going to be positive, and I have to go up 4 points to get to where the level that the A is at. So that's my y value. So this point A sits at -4, 4. If you went to -4 and 4 and saw where they crossed, it would be at point A. Number 2 is point B. Same process, okay? X first, right or left, how far am I going? Well, this time we're going to the right. It's positive. X to the right is positive. X to the left is negative, right? Y up is positive. Y down is negative. So I'm going over to the right to x equals 4. Because my B is right here, lined up with my x equals 4. Well, what about my y? This time my y is negative, right? So how far down did I go to get to my point? Well, I went a -1 square. So at the point 4, -1 is my point B. Point C is right here, okay? So first is my x value. How far right or left do I have to move? Well, I don't move anywhere off of my origin point, right? The x, this value, this point lines right with the origin. That tells me that my x is 0. I didn't go any points to the left or the right, okay? But I do move up for my y, and how far up did I move? I moved 1 point. Number 4 is the letter D. And this time I have to travel on my x-axis, right? And I traveled over here to -3. So I know my x value is -3. But do I leave the axis? I don't, right? I don't go up or down at all. Point D is right on the x-axis, and that tells us that my y is 0. So if a point lands on the y-axis, my x is going to be 0. If a point lands on the x-axis, then my y is going to be 0. Okay, so keep that in mind. Now let's look at the next ones. Problems 5 through 8, they want us to label these points, plot them and label them. Now they don't give you any particular letters to use, so you can use whatever you want. I'm going to go ahead and label these E, F, G, and H, just to make it simple, okay? You don't want to just leave a dot floating there without a name. Every dot, every point you plot should have a name, okay? So first plot, number 5, it's at the point 1, 0. So my x is 1 and my y is 0. That tells me it's going to be on the x-axis, and it's going to be on the x-axis at +1, right there. And we're going to label it E, okay? For number 6, I'm going to the point 2, -5. So I know I'm going to be at +2x, -5y, and wherever they come together, I put my point. And that's letter F. All right? Number 7, I'm plotting the point 5, 3. So on my x-axis, I go to 5, and my y, I go to 3. And where do they connect? Right here. And that's letter G. And for number 8, I'm plotting the point -4, -4. So I want -4 on my x and -4 on my y. Where do they come together? Right there. And that was H. Now, as we're getting started here, because the next bunch of questions is about the coordinates, as we're getting started here, feel free to label your coordinate. That's quadrant, sorry, not your coordinate, your quadrant. That's quadrant 1. So this is quadrant 2, quadrant 3, and quadrant 4. Always in Roman numerals, please. Let's stick with that because that's how we label them. Numbers are great, but these are Roman numerals we use for quadrants, okay? So now they want us to know, they want us to name each quadrant that this would be in. Now, some of these numbers are huge, right? They're not going to actually fit on this chart. So you could look back over here and see quadrant 1 is positive, positive. Quadrant 2 is a negative, positive. Quadrant 3 is negative, negative. Quadrant 4 is positive, negative. Or you could just use your chart here, your coordinate plane, as an example. Like -100 is x is going to be way over here somewhere, right? And then -6 is down here. So that's definitely here in quadrant 3. For number 10, we've got +3. So we'd be this way. -70 would be way down here, but we're going to be in quadrant 4 regardless. Number 11 is a +79, -79. So positive would be way over here, off the page, off the screen. And then negative would be way down, off the page, off the screen, but still quadrant 4. For number 12, we've got +392, +201. Well, we know that positive are going to be way over here, and then up is going to be in quadrant 1. -181, +37. So now I'm going this way, but then up, and that's quadrant 2. And the point 0, 78. 0 meaning I'm not going to go to the left or to the right, but then I'm going up 78. So am I ever going to be in a quadrant? No, right? I'm going to be on the y-axis. All right, my point is going to be on the y-axis, and so we label that as the y-axis. If it was on the x-axis, we of course would label it x-axis, but this time it happens to be on the y. It doesn't fall into a coordinate. It's right on the axis. So we just need to be careful when we're labeling these that we keep our numbers in the correct order, okay? That's why it's called an ordered pair. X first, then y. So we find, and I'm just picking a random point here, if my x is -3, okay, I go to the left 3 points. If my y is a +3, I go up 3 points, and then where do they cross each other? And that would be right here, okay? And that's my example point. So we'll call it EX. So just make sure you're combining those and then finding where they meet. X always first, then Y. Same here when you're plotting points. And then remember our quadrant, the positive spot here, upper right corner is always quadrant 1. Then go counterclockwise with 2, 3, and 4. That's lesson 7. Lesson 8 begins on page 32, and it's titled Graphing Inequalities. Now, an equation that shows two expressions are equal, that's an equality. We do those all the time, right? X equals 9. But an inequality shows how the values of two unequal expressions compare to each other. We've all used the less than symbol and the greater than symbol. Okay, here X is less than 9, here X is greater than 9. Inequalities usually have an infinite number of solutions, but there's a place that they have to begin, okay? It's not x equals everything, or x is greater than everything, or x is less than everything, right? There is a place that they have to begin. So say we have this x is less than 5. We start at our 5, but we have to put an open circle. And what that means is just a circle we don't fill in. It's not a dot. And the open circle indicates that 5 is not part of the solution, okay? It's just where we are starting. And then because x is less than 5, we're going to the left. So 5 is not included because x is everything less than 5, okay? But now if we had a less than or equal to symbol, then we put a solid dot. The solid dot shows that that number is included in the answer. It's part of the answers. So x is less than or equal to 5 is a solid dot with an arrow going to the left. Okay, we put an arrow because we can't possibly show all the solutions because it goes on and on forever, amen. It's every single number less than 5, okay, and equal to, in this case, 5. So we draw an arrow to show which direction we're traveling. So let's look at these. Number 1, x is less than -7. Now, obviously, they've given us a very small little chunk here, and that's totally fine because what we can do is pick somewhere in the middle to put our -7. I'm going to put mine right here because this makes this a -6. This is a -8, and this is a -9, okay? Remember, when we're talking about negatives, they kind of go in the opposite direction that we're used to. X is less than a -7, so my circle is going to be open. Now, I usually put it above the line. Like here, they did it right on the line, right? I usually put it above so I can see it more clearly. Feel free to either do it in the line or above, but I need to clearly see your arrow. All right? So because x is less than 7, we're going to go to the left because -9 is less than -7. But the 7 isn't included, so it's an open circle. For number 2 here, we have x is greater than 10. So I'm going to pick 9, 10, 11, 12. You can see I've kind of shifted my 10 to a different spot than I put my 7, right? Because I want to have room for my arrow. And I know because x is greater than 10, my arrow is going to the right this time. So x is greater than 10. Open circle because 10 is not included. And greater than means we go to the right. Okay? 10, 11 is greater than 10. 12 is greater than 10. All right? Number 3, we have x is greater than or equal to, greater than and equal to, sorry. Now, -2. Okay. No, it is or. Okay, greater than or equal to -2. Now, greater than tells me I'm going to the right. So I'm going to put my -2 here, which makes this a -1, and that is 0, and a -3. Now, you don't have to fill these numbers in. I don't honestly care. I'm just doing it for you guys. If you just want to stick your -2 there and go from there, that's fine. So it's greater than or equal to. That tells me I've got a solid dot, all right? And then I go to the right because the right is greater than. 0 is greater than -2, okay? Number 4, x is greater than or equal to 7. So we've got 7, 8, 9, here's a 6. Solid dot, because it's got the equal sign, greater than or equal to, greater than, we go to the right. Okay, let's do some more of these at the top of page 33. For number 5, we have x is greater than a -47. Again, we've got to find our -47 point. This would be -46, -45, -48 over here. My x is greater than, so I'm going to the right, but I don't have an equal, so it's an open circle with an arrow to the right. The arrow kind of follows the direction of our sign here, right? Our sign is pointing that way because that's the way the arrow goes. Here, our sign is pointing this way because, well, no, that one doesn't work because the x is on the wrong side. This one my arrow's pointing this way, so it's going to go that way. This one is a little bit different because they've switched the terms around. -4 is less than x. You could rewrite that as x is greater than a -4 if it makes more sense. All we did was flip the whole thing over. Okay, the x is still by the open side of the sign, and then the -4 is on the other end. So x is greater than -4, or -4 is less than x, okay? Same thing, but x is greater than -4, so I've got my -4, -3, -2. This would be a -5. Greater than, meaning it's an open circle, okay? And greater than, meaning we go to the right, okay? We point, if our x is on the left-hand side, this is how it points in the right direction. So here we have x is greater than or equal to a -16. So -16, -15, -14. We got a -17 over here. Greater than or equal to tells me I've got a solid dot and I'm going to the right. Okay, pointing to the right. Here I have x is less than or equal to 52. So 52, 53, 51 would be here. 50 would be there, right? So less than or equal to tells me I have a solid dot, okay? And less than tells me I'm going to the left, okay? That's the way it's pointing. So when the x is on the left-hand side, really the greater than or less than sign really points us in the right direction, okay? So when we have just a less than or greater than, we have an open circle because the point we start at is not included in our answers, right? But when we have a greater than or equal to or less than or equal to, then we have a solid dot because the point we start at is included in the answer. Greater than, we're going to go to the left. Less than, we're going to go to the right. Don't let these trick you here. Rewrite them so that you know which way you're headed, okay? Put the variable on the left-hand side. That's lesson 8. Lesson 9 begins on page 36, and it's titled Graphing Two Variable or Linear Equations. Okay, last week we were working with finding our ordered pairs solutions for these two variable linear equations, and now we're going to look at graphing them, right? So it tells us in lesson 4.4, we learned how to find those ordered pair solutions, right? We usually found 3 of them, but there's an infinite number. Well, graphs are useful for representing that infinite number of solutions. So for this one of x equals y, they found 5 points. 5 points is pretty obsessive. 2 points determine a line. We find 3 points to make sure we have our line correct, and we go from there. 5s is a little bit much. But what they did then, once they found their 5 points, is they plotted them all. And if you took a ruler, I only have my big one here right now, you would see that they all line up and could be connected into a line. And then everywhere that line is a solution to the equation y equals x, okay? Anytime several ordered pair solutions to a two-variable equation are plotted on a graph, they will be a straight line. That's why we do 3 to check our line, okay? Because two-variable first-degree equations graph as a straight line, that's why they call them linear, okay? And this first degree just means that this is not a y squared and this is not an x squared. They're just both to the first degree. So looking at page 37, we see that our note here says to find 3 ordered pairs that make the equation true, select values for x in the equation and solve for the corresponding values. So here is their y equals x plus 3. Okay, they've chosen 3 values and solved, and here are their ordered pairs. They plotted those ordered pairs and then connected them with a line. That's really the crux of it. That's how we do it. Here are the steps condensed together. Review those. But what we want to do, find our 3 sets of ordered pairs, plot them, connect them with a line. If they don't line up, you made a mistake somewhere. You need to go back and check your math. So let's turn the page and do some of these. So at the top of page 38, we are given the linear equation y equals negative 4x plus 3. And they've given us our x values. So I'm going to start my xy chart, okay? Again, you can do this however you like. We're using the points negative 1, 0, 2, and we're going to solve for that. So when x is negative 1, y is negative 4 times negative 1 plus 3. Well, negative 4 times a negative 1 is a positive 4. 4 plus 3 is 7. So when x is negative 1, y is 7. That's our first ordered pair. Next one, when x is 0, y is negative 4 times 0 plus 3. Well, negative 4, no, that's a weird 0. Negative 4 times 0 is 0. 0 plus 3 is 3. So our next ordered pair is 0, 3. When x is 0, y is 3. For the last one here, we have a positive 2. So when x is 2, y is negative 4, times 2 plus 3. Negative 4 times 2 is a negative 8. Negative 8 plus 3 is a negative 5. So my coordinate point for here, my ordered pair is 2, negative 5. When x is 2, y is negative 5. So now let's plot our points. Now this grid is very small, so you need to be careful. They've marked it only in increments of 5, but every block represents 1. So here my point is negative 1. My x, remember we've got x, y, okay? So my x is a negative 1, and my y is a positive 7. So here's 5, 6, 7. So they come together right here. Now these points we don't have to label with a letter or anything because that's not what, we're not just graphing a point, right? We're graphing a line. My next point is at 0, 3. So I'm not going to move to my right or left. My x is 0, but then I'm going to move up 3. So 1, 2, 3, and I put a dot there. And my final coordinate point is at positive 2, negative 5. So I'm going to move to the right 2. So that's 1, 2. And then come down here to this negative 5 and put a point. Okay? Then you can get out your handy ruler, line them up, and draw your line. Now remember, when you're drawing lines, we put arrows at the end, just like you have on your axis lines here, because lines go on and on forever. Amen. Unless otherwise stated, right? So that is the line that represents this linear equation. And any point on that line, like this point that looks like it's probably a 1, 0, is a solution to this equation. All right, every single point, all the ones that fall in the middle, every single one is a solution to this equation. All right, let's look at number 2. For number 2, they've given us x minus 2y equals 6. Now we need to rewrite this in our y equals format, right? So I'm going to add the 2y to both sides. So I'm left with x is equal to 2y plus 6, right? Now I'm trying to get this y by itself, so I'm going to subtract the 6 from both sides. Now I have this 2y is equal to x minus 6. This 2 is being multiplied by y. We're going to do the opposite and divide every term. All right? So I'm left with y is equal to negative 6 divided by 2 is negative 3. And x divided by 2, here's how we're going to write this. We are going to pull the x out, and that's going to leave us with 1 over 2 times x. So this is basically 1/2 of x, right? X divided by 2 is half of x. So we write it like this. Now what I'm going to do is flip this equation over so I have it set as y equals instead of all this equals y. And basically we just flip every term. Y equals 1/2 x minus 3. So here is the equation that we're going to use now for our XY chart. And they want us to use the points 2, 0, and 4. I like to keep mine in numerical order. They apparently don't care. However you like to write yours is fine. So when x equals 2, Okay, y equals 1/2 times 2. See, that's why we pulled the x out. It makes it a little bit clearer. Minus 3. Well, 1/2 times 2 is just 1. 1 minus 3 is a negative 2. So when x is 2, y is a negative 2. What about when x is 0? Well, when x is 0, y equals 1/2 times 0 minus 3. Well, 1/2 times 0 is 0. 0 minus 3 is a negative 3. So when x equals 0, y is negative 3. And what about when y is 4? Sorry, x equals 4. Well, when x equals 4, y equals 1/2 times 4 minus 3. Half of 4 is 2. 2 minus 3 is a negative 1. So when x equals 4, y equals negative 1. Here are our coordinate points that we're now going to plot. Here I have x is equal to positive 2 and y is equal to negative 2. That's the point right there. I went to the positive 2, x, negative 2y. Here I have 0x, negative 3y. My x is not going to move right or left. It's going to be on the y-axis, and it's going to be at negative 3. We count down 3 blocks, okay? And the last point is at positive 4, negative 1. So I'm going to come over here to positive 4x and go to negative 1y. I got like a little extra thing there. These are kind of all in a little row, right? We're going to pull out our ruler, draw our line, and I usually draw my lines going past the coordinate plane to show that this line goes on and on forever. Amen. All right, looking at these last two examples here. For number 3, we have 3x minus y equals 2. Again, we have to get our y by itself. Y equals something. Since my y is negative, I'm going to do the opposite and add y to both sides. So I have 3x equals 2 plus y. I got to get rid of this 2, so I'm going to subtract it from both sides. So I have y equals, right, 3x minus 2. Now I'm going to switch them around. All you do is switch what side of the equal sign they're on. So y equals 3x minus 2. There's my new equation. Setting up my chart. They want us to use negative 1, 1, and 2. Okay. So when x is equal to negative 1, y equals 3 times negative 1 minus 2. 3 times negative 1 is a negative 3. Negative 3 minus 2 is a negative 5. So my coordinate point is negative 1, comma, negative 5. What about when x equals 1? Well, when x equals 1, y equals 3 times 1 minus 2. 3 times 1 is 3. 3 minus 2 is 1. So when x is 1, y is 1. What about for 2? Well, when x equals 2, y is going to be equal to 3 times 2 minus 2. 3 times 2 is 6. 6 minus 2 is 4. So my coordinate point is at 2, comma, 4. Here are my coordinate points that now I can graph, plot. So let's do it. The first point is at negative 1, negative 5. So I'm going to come over. X is negative 1, y is negative 5. They meet right about there. Okay, there's kind of a missing spot there because of the negative sign, but that's okay. What about at point 1, 1? Well, x is 1, y is 1. So it's right there. And my last point is 2, 4. So I go to x is positive 2, y is positive 4, and I put a dot there as well. Grab your ruler. This is a very steep line, as you can see, and you draw in your line. Arrows at both ends to show that it goes on and on. Okay, every single point where this line is a solution for this equation. Y equals 3x minus 2. Last one, number 4. 2x plus 3y equals 3 is our equation. Again, we've got to get this sorted out. This time, though, since our y is positive, we're going to move our x. 2x is positive. We're going to do the opposite and subtract 2x from both sides. And we're left with 3y is equal to negative 2x plus 3. Okay, you want to It seems counterintuitive, but when we're writing linear equations, usually the x comes first and then the constant. Now, my 3 is being multiplied by y. We're going to do the opposite and divide every term, okay? 3 over 3 is 1, so we're left with y is equal to. Now, just like we did with that 1/2, we're going to pull the x out of this fraction. You can kind of see the fraction right here, right? So it's -2/3, and then put the x on the outside. 3 over 3 is 1. Okay, and now they want us to use the points -3, 0, and 3. All right, so let's do that. When x is -3, y is going to be equal to -2/3 times 3 plus 1. Well, this 3 over 3 cancels. So I've got -2 plus 1, or -1. My coordinate there, I'm going to write them down here because I ran out of room, is -3, -1. What about when x is 0? Well, when x is 0, y is equal to -2/3 times 0 plus 1. -2/3 times 0 is 0. 0 plus 1 is 1. 0 is one of my favorite x's because it just cancels out everything that's right here, right? And all you're left with is this part. So when x is 0, y is 1. What about when x is 3? Well, when x is 3, y is equal to -2/3. Oh, this was supposed to be a -3. Shoot. That's a -3. -2 times a negative gives me a +2. +2 plus 1 gives me a +3. Okay, see right there, we caught an error. This was a negative. Negative times a negative is a positive. Just because our 3's cancel, that negative is still there. Negative times negative is a +2. +2 plus 1 is a +3. Everybody makes errors, right? Good thing we checked our work. Now, for this +3, we have a -2/3 times a +3. We already know the answer because we did it for that problem up there, right? On accident. The 3's cancel each other out. We have -2 plus 1, which is a -1. So now, if x is a +3, y is a -1. All right, we just messed up. We forgot our sign. We got to be careful with our signs. So let's plot these points. X is -3, so I count over 1, 2, 3 to the left. Y is a +3, so I go up 1, 2, 3 up, and I put a dot. Here my x is 0, so I'm not moving left or right, but my y is 1 positive, so we're going to go up 1 point. And then here I have a +3x, so I'm going to the right 1, 2, 3 points, but a -1y, so I go down 1 point. And I put an x, or a dot, sorry. Using my ruler, I connect the dots and I draw in my arrows. All right, so on these problems, most of them you're going to have to solve for y. We need it in a y equals format, okay? Then we can put in our points for x and solve, and what would our points for y be? Giving us our 3 set of coordinate points. Once we have 3 coordinate points, we can graph them, plot them, and then connect them in a straight line with our ruler. Now, if they don't connect in a straight line, then you've made an error. Go like this point would not have connected, right? It would have been wrong when we had this -3, what was it? -1, because it would have been -3, it would have been over here. Well, this point here and those 2 points wouldn't have matched, right? I would have said, oh, definitely had an error. I caught it before that we got to that point, but recognize that if they don't form a straight line, you have an error. You need to go back and check your work. Now, in the book here is your light unit test. Make sure I fold mine in half so it's out of the way. Make sure you don't miss the rest of lesson 9 though, because the test is stuck here in the middle. Okay, so don't forget to do the rest of lesson 9 that continues after your test papers. But that's it for today. If you have any questions going forward, please don't hesitate to contact me, or you can meet me in my office hours. Otherwise, until next time.